Welcome to the D&D learning series. Today we are going to see about the microcontrollers that we are having in our lab, especially the Arduino series that we have in our lab, and we use it for different projects. So first of all, we'll see what are the types we are having. We are having Arduino Uno, Mega and Nano. These are the three different variants we are having in our lab. So let us see in details about each and everything. So Arduino is a company. You can say that Honda is an example. So Honda is having a bike like Activa, Unicorn and so many series. So similar way, Arduino is an open platform and it is developing a board. So microcontroller, basically we are having a Atmega 328 or different microcontrollers, but to have a platform or to have a development board, we are having a Arduino in it. That means Arduino is using this microcontroller and giving us a platform. So this we are having a 3 in series. So let us see in details about all of these. As I said that Arduino is having a platform, so it is having different boards. Not only these three, they are having different boards. So you can see this, they are having different series in it. So let us see in detail about each and every component we are having. Arduino Uno, first of all we will see about it. Arduino Uno, you can see in picture. Let us start from the power point. So power port, from here we are actually powering the board. We can power it with 7 to 12 volt and the allowed voltage is 6 to 20 volt. So the functioning voltage of this Arduino Uno board is 7 to 12 volt. And to control or to regulate this voltage, we are having a voltage regulator. You can see that voltage regulator there. And you can see the USB connector. So USB connector, we use it to power it as well as to download the program or upload the program to the board. The program that we use to program the microcontroller. The reset switch. This reset switch we use to reset the program and not to erase. So keep in mind. So when we press this, the program which is executing in between, we can make it to start from the beginning. So that is what about the reset switch. So coming back to these pins, so there are different pins we are having, digital pins, you can see that, and there are two LEDs also, small RX and TX. RX and TX LEDs will glow when any data is being transferred or received. If it is received, then RX. If it is transferred, then TX. You can see the microcontroller that we always talk. The microcontroller we are having here is Atmega 328P. And after that, at the bottom, you can see analog input pins. Analog input pins we are having in it. And parallelly to that, we are having a power section. So in the power section, we can see the pins. And we will see all these pins in detail in a different image. Also, I would like to mention here the microcontroller that we are having 328P can be in a different form. Means sometimes if you see your Arduino Unos, those will look something different like this. So this is also an Arduino Uno but with SMD. So this is the SMD and it is having some extra pins also like GND, VCC and all these things. So this is a different but having a same platform. So in this image we'll see the detailed structure from the left side. First is the power section. In this power section you can see the first one is not connected, that means it is not in use. Second one is input output reference voltage. If you want to have any input output reference voltage from this, you can take it. Third one is a reset. So instead of pressing that reset button, you can press the reset or you can reset the Arduino from this pin also. There are 3.3 volt and 5 volt output pins and GND, and you can see that. So GND and VCC we talk in any sensors. So those connections will come to these points. Then there is the input voltage. So what is that input voltage means? Input voltage means sometimes we power generally this board from there, that 7 to 12 voltage with the USB jack. But you can power it externally also with 7 to 12 voltage. So that happens from this input voltage pin. After that, you can see there are analog pins. We are having analog pins A0 to A5. These are analog input pins, analog signals, what we are coming from the input devices that we already discussed in our earlier videos. So those input devices will give the signal from there and those signal will be received by this controller through these pins. There is SD and SCL also. Those are used for the communications. After that, you can see that Atmega 328 microcontroller IC chip in it. So this is the thing which is the main core of this board which is processing all these things. But meanwhile, So there are some pins after that which is written as ICSP for Atmega 328, and it is having 6 pins. So what is this ICSP means? We'll see in detail. So ICSP means in circuit serial programming. In circuit serial programming, it's a method to program the microcontroller. See, in our computer we used to install the Windows. Similarly, we should have a firmware to work for this microcontroller, and that will be done through these pins. And same pin you can find it there at the top, that is written as ICSP for the USB interface. And for the USB interface, we are having one more Atmega small microcontroller, that is Atmega 16U2. There you can see that in the circle. So these are the two ICSP pins that we are having on the Arduino board. Coming to the digital pins. Digital pins, we are having these 0 to 13. These will act as input as well as output. Means these can take the input signal as well as it can send the signals out from this microcontroller board. Out of these, there are two initial 0 and 1 which are used as TX and RX. So TX and RX, that will be used for the transmission and receiving of the data from the other devices. Remaining 2 to 13, in that you can see there are 3, 5, 6, 9, 10 and 11. These are the pins having some different symbol in front of it. So what that means? That means these are the pins which are having pulse width modulation. So what is that pulse width modulation? Pulse width modulation pins will be used to control the servo motors, because servo motors needs the pulse width modulation, because sometimes they will be moving for 0 degrees or 90 degrees or 180 degrees. So these variation in the rotation will be controlled through the pulse width modulation. So if you want to see in detail what is that pulse width, see, for a 0 degree, if it is at the 0 degree, the pulse width will be 1 millisecond. Then if we are taking it to the 0, that is 1.5, and if you are taking it to the 180 degrees, then it will be 2 milliseconds. So this is the pulse. Depending upon the area or the angle it is traveling, the width of the pulse will increase to power it more to cover that rotation. This is a if you want to technically see that, you will get more details on the web. There are 3 LEDs on this, RX, TX, and the last one is actually a pin number 13 LED. That means if you see in a digital pin, there will be a pin number 13 which will be interconnected to this LED. So when you take a new Arduino and as soon as you power it, immediately this LED will start glowing. So that means it is interconnected to the pin number 13. So this is about the Arduino Uno. I hope you understood all about this Uno in this, and the remaining components that you are seeing on this are small, the resistors and the capacitors depending upon the requirement, crystal oscilloscopes and all voltage regulators that we saw. So let us go to the next board now. Our next board is Arduino Mega. Arduino Mega is one of the series of this Arduino. So there is no any difference in terms of functionality of this Arduino boards. The difference is only in terms of the number of pins and its arrangements. So here in place of Arduino Uno we are having Mega, and only difference is the number of pins we are having in it. So if you see that in the power section, there will be same, there is not much difference in this. Power source, USB connector and a reset button also, there it is. And if you see, the difference is only its microcontroller. The difference is only its microcontroller. There it was Atmega 328P. Here it is Atmega 2560. Okay. And the difference we are having here is we are having more number of digital pins. So if you see there in Uno, we are having only 0 to 13. But here we are having 0 to 53. That means those many number of pins we are having in this, and that is very beneficial for having the large scale projects. Parallelly we are having a 0 to 15 analog input pins. There we were having only A0 to A6. Here we are having A0 to A15. As well as there we were having only 3, 5, 6, 9, 10 and 11. These are the only pulse width modulation output pins. But here we are having 2 to 13. That means 12 pins. In place of 6 we are having double. We are having 12 pulse width modulation pins. As well as we are having a serial communication pins. There we were having only 0 to 1. in the Uno, but here we are having 0, 1, 14, 15, 16, 17, 18 and 19. That means we are having 4 sets of RX and TX and 12 pins for the pulse width modulation. Apart from that, there are pin number 20 and 21, which is called as TWI. So what is this TWI? This is two wired interface or I2C, inter IC. So this is used to communicate between the two ICs. Here we are having 5 GND pins, 2, 2 and there is 1. So that is the benefit of having this mega. That means we are having more number of pins. Operating Arduino platform, same IDE, there is no any difference. Coming to the third one, which is Arduino Nano. This we can call it a chota packet bada dhamaka. Okay, because see in this power source is microcontroller, like it is having Atmega 328P, same in the SMD form that I told. Here you can see digital pin D2, D13 and T13 is there at the bottom. So there you can see that digital pin number 13 here at the bottom. After that we are having normal power section, that is 3.3 volt output and 5 voltage output. Then we are having a reset pin. Then we are having a GND and voltage input. This GND is related to the input voltage. Okay, that means when we are putting a positive to the VIN, negative will go to the adjacent GND where we can apply the voltage to this this Nano. Here we are having analog input pins A0 to A7. See, in the Uno we are having only A6, but here we are having A7. These are the 4 LEDs we are having: TX, RX, PWR, that is power, and the last one is 13. That means digital pin number 13 LED, which is interconnected to the digital pin number 13. This will glow accordingly. When the data is coming, then it is RX. Then when the data is going out of this board, then it is TX. If the power is supplied to this board, then PWR, and if you are powering the digital pin number 13, then the pin number 13 LED, which is yellow in color, will glow. So this is about the Nano. So the difference between all these three is only in terms of number of pins and their microcontrollers, but the working or the software that we are using is same, IDE, integrated development environment. We'll see about the software in the next coming videos. Thanks for watching.
Hope you enjoyed the video. There are many videos regarding the Tinkering Lab there in our channel. Please do encourage us by subscribing our channel, and also suggestions or any remarks or any doubts, please do in the comment box. Keep learning, keep tinkering.